Okay, so this mole unit is basically a mini unit that's going in between our measurement one that we just finished and the one that we're about to start over atomic theory. So we're going to start with what is a mole. So we talked about mole day briefly, but a mole is first of all going to be abbreviated as MOL. And I point that out because we also use the word molecule in this class all the time, and we are not going to abbreviate molecule as MOL. That's going to be abbreviated as MC. So if you abbreviate something MOL, that is a mole. A mole is going to be equal to, so 1 mole equals 6.02 times 10 to the 23rd things. So I always equate this to a dozen, where 1 mole represents that number of whatever it is that you're talking about. Similar to how a dozen, let me pull a different color. So if I said I want 1 dozen of anything, it doesn't matter what it is that I'm talking about. If I say a dozen, that means 12 things. If I say 1 mole, that means that many things. So it's just this number that we're representing. This number is referred to as Avogadro's number. So Avogadro's number. And then this will be the only time I ever ask you to write out the entire thing, probably. Don't hold me to that. But we usually write it in scientific notation, but because I want you to understand what this number actually is, I want to write it out in normal notation like you're used to seeing numbers. So first of all, if I look at this in scientific notation, does this value represent a really big number or a really small number? Really big number, because I have a positive 23 as my exponent, which means that I'm going to move my decimal 23 places, in this case to the right. So the first place will go 1, 2. So 2 spots are taken up by other digits. And then I would have 21 more spaces after that, which means that there are 21 zeros tacked onto the end. So I want you all to write this number out of 602 and then 21 zeros. So a really, 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 really big number. Thank you. And then number 3 on this, I'm going to say that 1 mole equals 6.02 times 10 to the 23rd atoms, or formula unit, or I'm going to say molecules in that order, so it follows this one, or molecules, or formula units. So atoms, or molecules, or formula units. So that's where we'll put that number. All 3 of those things are what we would refer to as representative particles. We really don't use that word that often because it's not very specific. But representative particles just mean really small things. So if you hear the term particle, that is a real word, but it's not very descriptive. So when we talk about particles, you could be talking about atoms, or you could be talking about molecules, or you could be talking about formula units, depending on what the actual chemical formula for something is. So a representative particle is just something small.
How long is this fucking word?
21 zeros at the end.
All right, good. Thank you.
You're welcome. So an atom, and this is kind of something that we wrote on our periodic tables when we first got them, but we wrote it sort of out of context where you didn't know what it was. So an atom is just talking about any single element from your periodic table. any single element from your periodic table we can refer to as an atom. And then a molecule, we will abbreviate that one as MC. So you'll notice these things written on your periodic tables at the top. So we have compounds, then we have MC, and then FUN. So MC stands for molecule, FUN stands for formula unit. If you have your same periodic table that we got earlier in the semester, you probably have some notes written on there. So a molecule is a covalent compound. And covalent compounds are made up of nonmetals only. And then a formula unit, that's the one that we abbreviate as FUN, because formula unit. A formula unit is going to be an ionic compound. And ionic compounds are made up of a cation plus an anion. Or usually that's going to be a metal, and usually the anion is a nonmetal. We'll learn more about that later on. So from pretty informal polls of my classes, it seems like a lot of you haven't had much, if any, experience working with your periodic table before. So if you're dying to know what nonmetals versus metals are on your periodic table, those are the only two real classifications that we have of things on here. So if you're looking at your periodic table, and we'll talk about this in later units as well, this little zigzag line, the dark line here, separates your metals from your nonmetals. So one side of your periodic table, so the majority of your periodic table is primarily one thing, and the other side is primarily something else. Students often get them confused, but my trick for telling which side is which is think of any metal that you have ever heard of in your normal life. Do you know any metals off the top of your head? Steel is a metal, yeah. Iron is a metal. Copper is a metal. Gold is a metal. Lead is a metal. Tin is a metal. Okay, so any of those things, yeah, you said iron, right? Oops, sorry. If you think of any of those, find where that element is on the periodic table. So steel is not an element. Steel is an alloy, and we'll talk about alloys later. But any of the others, if you can think of a single metal that you've interacted with in your real life, like most of you have heard of silver and gold at least, or probably nickel or copper or iron or something along those lines, if you find where that element is on your periodic table, that element is going to be on the metal side. So, for example, if you know, hey, copper is a metal that I've heard of in real life, copper is on this side, which means that this whole side, on this side of that staircase, the little zigzag line, that's all going to be metals. And things that are not on that side are called nonmetals. Simple enough? People try to overcomplicate it. It's not hard. Okay, I'm going to pause this one here and start a new video.